So let's say initially that you were not moving, but over a time of 15 seconds, you sped up to a speed of 8 meters per second. And how far did you travel in that time? Or in other words, find the distance. Well, first of all, let's just note that we made an assumption here. And the assumption is that we sped up at a constant rate. It was the same acceleration throughout. We didn't go really quick and then really slow or change the acceleration. We always increased our speed at a constant rate. What I'm going to do next is I'm going to identify any values that I have here. I see that my time is 15 seconds, or that might be my delta time. It's the same thing in essence, because what this is telling us that our initial, when we started the clock, it was at time 0, and we traveled 15 seconds. We also have 8 meters per second. And what is that? Well, that is a velocity. It's our final velocity. And or technically it's a speed because it didn't tell us what direction it's going. So I can't put the arrow over top because it's not a velocity, it's only a speed. The other thing that they've told us indirectly is that initially we were not moving, which means my initial velocity, my VI, is 0. And what do we want to find? We want to find D. So always identify the variables that we have and identify what variables we're trying to find. I've decided that I'm going to graph this problem just to set it up with a little velocity versus time graph. So I've got a title, I've got my labels. Remember, time goes usually on the bottom, velocity's on the side, and it's a constant velocity. It does not change from a velocity of 0 to a velocity of 8 over a time of 15 seconds. So I've got my graph all set up here. And what do I want to know is I want to know the distance that I traveled in that amount of time. Is what if I calculated the area under this curve? What will this area give me? Well, that's a triangle, a right angle triangle. And the area of the triangle is going to be 1/2 the base times the height. So we're just going to go back to our simple area formulas. And so what is the base? Well, the base on this one is 15 seconds. And the height is 8 meters per second. And if I do some quick mental math on this, I'm going to see that I'm going to end up with an answer of 60, and my units will be meters. Interesting. My units are meters. That to me looks like it's a distance. Distance is 1/2 the base times the height. So let's remember that the base of this graph is our time, and the height relates to our velocity. And in fact, what it does is the 1/2 of the height is actually the average velocity. And what we do is we take the final velocity, we add the initial velocity, and we divide that by 2 to give us this average. So we now have our first kinematic equation. The distance we traveled is going to be the base, which is time, times VF plus VI divided by 2. Is the average velocity multiplied by the time. And we're going to solve that for the word problem that we have. So we're going to see that the distance is equal to the final velocity, which is 8 meters per second, plus the initial velocity of 0 meters per second. Divide that by 2 and multiply it by your total. So once again, I'm going to have my distance is 8 meters per second. Divide that by 2, multiply it by 15. So my distance will be 60, and looking at my units, I'm seeing in the units here of meters per second times seconds. These units will cancel out, and I end up with a final distance of 60 meters. If it works for another problem here. So like I did last time, I'm going to identify the variables here. I see that we have a speed of 10 meters per second. It doesn't tell me if it's north, south, east, or west, so it's only a speed. And it's going to slow down. So my time, or it could even be my delta t, but its time is 5 seconds. And then I see it's going to have another speed. So this is another speed of 6 meters per second. So I have an initial speed and a final speed, or it could be speed 1, speed 2. Okay. And once again, how far did it travel? I want to know my distance. So first of all, write down your variables. Once again, we know that we have this equation that we found that the distance was equal to the average velocity. So we're going to say our initial velocity plus our final velocity. Divide this by 2 and multiply it by time. Okay, so our distance is going to be the initial velocity, 10 meters per second, plus our final velocity, 6 meters per second. Divide the answer by 2 and multiply it by the time, which was 5 seconds. Distance will be 16 meters per second divided by 2 times 5 seconds. 8 meters per second times 5 seconds. Distance will equal 40. And look at this. Our units, once again, we always check our units. It tells us if our algebra is working well. Seconds on the top, seconds on the bottom. We're left with a distance of 40 meters. Manipulate it. So here's a new problem. We have a car traveled 10 meters. So we get a distance this time of 10 meters. And what we see is that it went from 8 meters per second. So that's an initial speed of 8 meters per second. And we have a final speed of 6 meters per second. And this time, the question is, what is our time? So we're going to go back to our original equation. We know that our distance was the initial velocity plus the final velocity divided by 2 multiplied by time. So what we need to do now is we need to do a little bit of algebra here to manipulate things. So the first thing I'll do is I'll get that 2 up top. And so I'm going to say that 2d is my vi plus vf multiplied by t. And then if I divide each side by what's in brackets here, my change in velocity, it's not my change, but my velocity total, what I'll see is that 2d divided by vi plus vf, there's my formula for time. And what we need to do is get good at manipulating these equations to do that. I'm just going to reverse it around here. So we're going to say our time is equal to 2 times the distance divided by my initial velocity, which was 8 meters per second, plus 6 meters per second. So my time is going to be 20 meters. Divide that by 14 meters per second. Okay, and take out my calculator here. And 20 divided by 14 equals 1.428. How about I'll say 1.4? 1.4. And we have meters over meters per second. And you should watch the unit talking about how to manipulate units, but that is going to give us 1.4 seconds. Right. So we got a bicycle speeding up. It was traveling at a speed of 2 meters per second. I don't know which direction, so it's a speed. We have 12 seconds. That's going to be a time. And I have a distance traveled of 36 meters. And I want to know what is my new velocity. So I got a change in velocity. So I had an initial velocity of 2 meters per second. I want to know what is the final velocity. Okay. Once again, I'm going to go to my formula that my distance is equal to my initial velocity plus my final velocity. Divide that by 2, multiply it by your time. But I need to do some manipulations on that. So once again, I'm going to get rid of that 2 first. Going to put that over on the other side by multiplying. Once again, if your algebra skills aren't strong, you can watch some algebra videos. Okay, I'm going to get rid of that time. So I'm going to go 2d over time equals my initial velocity plus my final velocity. And now I can subtract the velocity that I have, and that'll give me the velocity I need. So 2d divided by time, subtract my initial velocity will equal the final velocity. When you get good algebra skills, makes it all easy. So I'm just going to rewrite it with the unknown thing on the left side. So I've got 2 times my distance. My distance was 36 meters. I can divide that by my time. That was 12 seconds. And then I'm going to subtract my initial velocity, which was 2 meters per second. Okay, so my final velocity will equal 2 times 36 divided by 12. I believe that's 6 meters per second. Take away 2 meters per second. Note that my units should always match up here. If one of them is in kilometers an hour and the other one's in meters per second, we're going to have problems. But my new velocity is 4 meters per second. So there you have your first kinematic equation solving all kinds of unknown variables.